Hi, I'm Gavin from AnyLogic. Welcome to our Rail Library webinar with Anand and Kelvin Yeung of DSE Consulting and Will Harley of WSP. We hope you will find the webinar informative and inspiring.
Gavin, thank you very much for the introductions. Hi everyone, welcome to this AnyLogic webinar. My name's Anand from DSE Consulting. This webinar today is going to focus on the new features in the AnyLogic Rail Library, leading to some applications of it within 2 UK national cases. These cases are going to show how AnyLogic has been used as the core platform for developing solutions that help move the rail sector beyond empirical analysis based on tacit knowledge towards more autonomous diagnostic and predictive systems based on simulations. Lastly, we will be presenting the Rail Library features available in version 8.7 of AnyLogic inside of our new Pocket Guide, as well as an example of the advantages of using Rail Library switch features with deep reinforcement learning in Pathmind. To summarize, we will jump into live mode for a quick Q&A session and provide some links to places where you can download the Pocket Guide and get more information. For those of you who don't know us, DSE are the sole technology partner to the AnyLogic company and have been since 2008 in the UK. We've recently begun to serve the Italian market as well with our range of technologies and support. The core platforms we use are of course AnyLogic and AnyLogistics. However, our technical specialists have recently also begun using AnyLogic models with complementary AI platforms like Pathmind. As a technology integration and simulation support company, we offer a range of services including bespoke modeling, official training, one-to-one mentoring, model auditing, amongst many others. The whole team have a deep expertise in data analytics, coming from a range of different industrial backgrounds, including aerospace, manufacturing, and healthcare. We also act as a bridge for our sister company Decision Lab, who offer a wide range of data science, machine learning, and optimization consultancy services. These are normally developed as end-to-end solutions that work within our clients' existing cloud-based execution frameworks. Before getting into the new Rail Library features in version 8.7, I'm going to pass the mic over to our partners at WSP to introduce themselves.
So yes, I'll deliver a couple of minutes on WSP itself. We're a leading international professional consulting firm, and our revenues come from professional services. So we're leaders in technical leaders in highways and transportation, civil infrastructure and buildings. So my experience is predominantly within the rail part of the organisation. I work in the rail planning and operations team. It's fairly extensive. I'm not quite sure what the exact size the headcount is, but we cover all aspects really of rail planning, rail operational planning. We have a particular focus on rail modelling, so we work across a number of platforms, which I'm sure many on the call will be familiar with. We use RailSys, RailPlan, Attune. I work in a lot in Excel with Visual Basic underneath it, mainly to do data processing really, or or transferring information and data between files. There's a lot of there's increasing amounts of data handling going on these days as the railway collects more and more information. I think to an extent we're all playing catch up a little bit with the amount of data that's being produced. So this has led us eventually to start to use AnyLogic and move into the world of agent-based and event-driven modelling. We've been doing this for maybe 2.5 years now. It's been a learning curve, but yeah, we feel like we're building up some good expertise. So just a couple of minutes about me. That's me in the picture in happier times when I could still leave my house. So I studied at aerospace engineering with variable results, and then after a couple of years gap, embarked on a career in the transport sector, all modes, but curiously enough I don't think I've ever worked with aviation, strangely. So the last 3 years I've been working in rail planning and operations, so that's been almost exclusively heavy rail work. and of those 3 years, I think I've been working with AnyLogic for about 2, on and off. Other than that, my skill set is mainly Excel and Visual Basic coding, so a lot of experience of building models in that environment. I've made a lot of mistakes over the years and I've learned a hell of a lot, but now I'm having to add Java to my skill set because you're going to need that if you want to work in AnyLogic, although the barrier to entry isn't too high, so you should be able to get going fairly quickly. But yeah, brush up on your Java if you have any free time. And the last thing is really developing opportunities in rail decarbonisation, because I think the net zero goal is very important, and I think there's going to be a lot of new work out there in that area. So I'm trying to brush up on my skills with that.
With the release of AnyLogic 8.7, there's been some big additions to the rail library. These include tracks that can be blocked and reserved for a particular train, as well as updating train positions on a track using callback actions. Also, there's been updates to the train move to block that enable warnings for when a train has not reached its target destination. New additions also include single sling and double sling switches that allow you to connect to more than 3 railway tracks at once. And train movement can now be paused and restarted, removing the need for multiple train move to blocks. Okay everyone, I'm now going to hand over to Will from WSP and Kelvin from DSE, who are going to show you the application of AnyLogic's Rail Library in a couple of UK national-based cases.
Hello, I'm Kelvin. Some of you might already know me. I'm a senior consultant at Decision Lab and an AnyLogic consultant at DSE. My main role at Decision Lab is to manage the integration between simulation models and machine learning agents. I work on multiple projects which involve connecting existing simulation models, or most often building simulation models from scratch, and interface them with AI frameworks. Most commonly in Decision Lab, we use deep reinforcement learning, but we do other machine learning methods as well. At DSE, I worked with the head of technology and training, and assist in delivering the AnyLogic workshops and one-to-one mentoring sessions. From time to time, I also often involved in doing quick hacks to put together some proof of concept models. I am a chartered engineer from the IMechE and an associate member of the Royal Aeronautical Society. Before joining Decision Lab, I worked in the rail industry as an engineering consultant. I worked on the Deep Tube upgrade program as a system engineering and integration consultant to manage system architectures and client requirements. I was also a track engineer and was involved in designing the Temple Green Depot for High Speed 2. My role then slowly migrates and lean more on operation modeling side of things, and that's when I started to develop my competencies in AnyLogic. I have extensive modeling experience with the AnyLogic Rail Library when I was working at WSP, with Will actually doing all sorts of depot modeling, which you will see in a bit. I have also hosted multiple internal and external webinars on simulations and modeling. The goal for this webinar is to give you guys some idea of the actual commercial applications of the AnyLogic Rail Library, as well as sharing some cutting-edge ideas on how to transform the AI to the real world. Later on, I will also be showcasing some of the new features in the Rail Library, as well as demonstrating some simple examples via the form of a Pocket Handbook. Towards the end of this webinar, you will be able to download the handbook for free. This webinar tries to build on our previous 8.6 MHL webinar with a new 8.7 rail-focused one this time. So if you have missed that one out, feel free to go on to the AnyLogic website or YouTube and search for it. As always, we are keen in supporting the AnyLogic community with new release features and some pragmatic application of these in use cases. As we were unable to do our annual simulation conference in the UK this year, we at DSE wanted to use this as our second opportunity to share the state of the art virtually of AnyLogic with new and existing users. I will now pass to Will, where he will talk about the commercial applications of the AnyLogic Rail Library.
So we were asked by HS2 to look at one of the depots which is under design at the moment on their future network. They were looking for a validation of the depot design operability, which differs from maybe the previous stage of a depot design, which is the raw understanding of the volumes required, the number of roads needed. This is more of a static exercise. You can do this on a pencil and paper exercise if you like, or spreadsheet, which is more likely, because you're not really looking at the way in which trains and track interact with each other. It's more just whether you have the physical space to park everything once you've got it onto the depot. It doesn't really take into account any movements or anything more dynamic. We needed something, a tool which would allow us to look at the actual operability of the depot using trains and track, and a scaled look, really, which would tell us whether we were getting into conflict and how easy it was to actually control the trains around the depot on a normal dev operation. We were also trying to look at the limits of the depot capability, how quickly it could admit trains in a perturbed or emergency situation. This was key when it came to the washer capability and the entrance road capability. We needed to take account of the diagramming and circulation, so just bringing trains onto the depot and then parking them overnight and sending them off was not sufficient. We needed to demonstrate that it was possible to shunt all the trains around and get them into the required formations for dispatch the following day, taking into account all the maintenance activity that needed to happen. And lastly, we were asked to look at key pinch points and limiting features of the depot, which might be reducing the depot's ability to deliver what was required, and whether we could suggest some solutions to that. So we used AnyLogic. It was perfect really for this task. We built a scale model of the depot and developed scale rolling stock units to impose on the model and run around the layout, and really played depots for a while and developed an operational plan to see if we could actually make the depot work. Why did we use AnyLogic? Well, it can do things that you'd have to be very, very capable in Excel to simulate on that platform. It's a scaled environment at track and stock levels, so what you see is what you would really get. Essentially, we designed the depot from PDF drawings, using those as a background, and drew the layout on top, so it literally was what you would get. It has conflict detection built in, really, so you can see if trains do collide with each other, or you make an illegal move, it will tell you. We had the capacity to build bespoke blocks in the functionality. That we used this for the train washing and the dispatch functions. We also exploited the reporting capability of AnyLogic, so it's very good for quickly putting charts and graphs up, and also exporting data to text files when certain events happened. And we also, what was also good was really the fact that you could run models at a high speed. You can change the time of the model, the refresh rate, so you can run through a whole day in a matter of minutes. And this also gave us this was very useful for debugging purposes. This is the process flow that we use to drive the depot model. It should be fairly clear that we broke this down into a number of repeated procedures which could be aggregated into one procedure with a more recursive approach, which I'll show you later. But for this, we felt it was worth breaking things down so that we could make debugging easy and actually see what was going on. Trains enter on the left and go through a train wash block, which was designed by WSP. They undertake whichever moves are required. We found 5 moves were enough to cope with anything that we needed to do in the depot, and then ultimately they move into the dispatch block, which is again a bespoke block defined by ourselves, which sends trains out to the north or south depending on what the train movement database said. I'm going to show you a bit of video in the next slide which shows this in action. This is a view of the model in action. You'll see there's a bit of train movement happening there. That's a train that's just come in, finished its handover and then moved into the maintenance siding. If we wait for a second or two, we should see another train come in. I'll pan across to look at the train wash area in more detail. That train just went into the wash and paused. We're running a little bit faster than real time here. We should see another train come in a second and do the same, undertake the same operation. So it's coming in, hold very briefly in our world at least, and then move on. And there's a pan out just to see some of the charts that you can put in, embed, and also just the overview that you get using the model. I'm now going to talk about some station modelling undertaken on behalf of HS2, really with Network Rail as the intended recipient. This is a much more of a visualization tool rather than an analytical tool, designed to communicate the impact that various timetables and layouts would have on existing services interacting with the potential new HS2 services. So it's cast from a different kind of direction and shows maybe a few more of the visualization options that you can have with AnyLogic when you're intending to communicate particular things in a particular way. Underneath the text here is this process flow was not used in this model, but this is our latest generation of process for movement. It contrasts with the depot movement process at the beginning in that it is recursive. It doesn't repeat the same set of modules over and over again. Trains can come into this loop round through the process as many times as they need to before ultimate disposal. This is Crewe station visualization in action. You'll see it's a more schematic representation. It doesn't contain scale information, so we're not trying to draw any particular analytics off it. This is really all about communication. The trains themselves are carrying head code information on their backs. We have some display board type information shown, which show how you can produce fairly bespoke outputs within AnyLogic. That's a format that's familiar to Network Rail, so that's how we did that. But yeah, so this is all about the communication element and how flexible AnyLogic can be in that, and you can really design your models to deliver whatever you want. So some final thoughts from an end user perspective. AnyLogic's been an excellent tool to use for looking at a number of rail problems that I don't think would be possible to address using our existing tool set. Get trained. The software package is extensive, so finding your way through it can be quite difficult to start with, so take advantage of AnyLogic's training capability if you can. The possibilities are endless, so beware scope creep. Define your problems very carefully and stick to that. Setup time is quite material, particularly if you're designing a big layout, so it might be a good idea to consider future use cases at the build stage, then you won't have to make changes later on. understand the debugging tools. There is a good debugging tool set in the model, and if you can design your model for easy debugging, like we did with our first model on the depot, it makes life easier. And at the present state of the of railway knowledge, I would say start with decision support models and engage with people working in the railway at that level. I think we can then move on to more autonomous functionality as familiarity with this kind of modelling grows. But I think Kelvin's going to talk more about this in a moment.
So hopefully, Will has given you an overview of how we can use AnyLogic to model rail movement. In this section, I am going to show you how we can extend the AnyLogic application and integrate it with some AI. At the moment, there are two platforms that support the training of AIs with AnyLogic, which is Pathmind and Microsoft Bonsai. When I mean support, it means providing an actual library with APIs to support in the training process. Of course, if you wanted to, you can connect the existing DRL framework, such as RLib, manually with a bit of Java as well. It's doable, and we have done it before, but it's not in the scope of this webinar. So before looking at the model, let's have a quick 3 minutes introduction to deep reinforcement learning. In here, we can see the famous Markup decision process. This diagram describes how an agent makes a decision based on the state and reward given to it. So start from the top, an agent triggers an action to the environment. The agent gets the state or observation of the environment and the reward. It then triggers another action, and this loop just went on. A quick example will be a person trying to ride a bicycle. In which case, the person is the agent. The action can be the person stepping on the brake pedal. This all happened within a park, which is the environment in this case. The state is what the person observes within this environment. So for example, front wheel position, body position, etc. Finally, the reward can be, for example, whether the person falls off the bicycle or not. This person then makes another action to try to maximize the amount of reward. So let's look at the model now. This is a simple model I built to try to demonstrate how we can connect simulation with AI. The training platform I use for this is Pathmind, or formerly called SkyMind. You can learn more about it by visiting their website. The logic of the model is quite simple. Two trains with random speed will arrive at this layout, one at the top and the other at the bottom. Train A at the top can either go straight to road A, or it may go to road B via this turnout. Train B at the bottom can only go to road B. Now imagine I'm now placing an AI on the top switch to decide whether train A should go to road A or road B. So remember from the previous diagram we saw, the agent in this case is a switch. It can do two actions, whether to direct the train to road B or toggle itself so to direct the train to road A. The environment in this case is the AnyLogic simulation environment. The reward is that if a train goes to road A, it's not that good, so -1 reward. Going to road B has much higher reward and a +5 reward. However, if there is a collision, there is a huge penalty, a -10 reward. The state of what the agent sees are both trains' speed. Since the agent is trying to maximize its reward, you can imagine that the agent will try to slot the top train to road B as much as possible, as that would give it the maximum reward. However, in certain scenarios, although it's lesser reward, the agent will slot the train to road A instead to avoid collision. It learns that by observing both trains' speed. I won't go through all the technical details on how to implement this and how to train it on Pathmind, as we have got limited time today. Maybe we can host another webinar next time specifically on that. I have already trained the model using Pathmind's web server. So what you are seeing right now is an already trained DRL agent. I'll run the model now. Let me just pause it quickly. So as you can see, the speed for both trains are randomized. The speed for train A is 10.457, which is much lower than train B's speed, which is 16.789 meters per second. So I would expect the switch to direct train A to road B because by the time train A arrives at this turnout, train B should already be in road B. Let me just run the model. And yes, indeed, the switch decided to route the train A to road B. Let me just try another combination and see if we can see the switch direct the train to road 8 instead. So the speed for train A this time is 17.55, which is much higher than the speed of train B, which is 9.185. So I'm still expecting the train A to be going down to row B. Yep. So I'm trying to find a speed where they are similar. So I think I've got it. So the speed of train A now is 17.268, and the speed of train B is 16.047 meters per second. I'm hoping this will do it. And yep. So this time the DRL agent decided to slot the train to row 8 instead, despite of the -1 reward. But as you can see in the reward structure, it wouldn't try to direct it to row B because it knows that if it do that, it will there will be a collision. Now, just review what I've done. I have basically feed in the observation or state to the trained agent, and it produces an action. People might say, you don't need an AI for that. It's just simply reading train speed and determine whether the trains will collide or not. Yes, you're right. You don't need an AI for it, but I'm just demonstrating the possibilities of it. So what's the real world problem then? In depot modeling, one of the challenges are to slot the trains at the right place so that it doesn't get delayed when leaving the depot in the morning. As Will said, there might be a lot of different activities going on, like maintenance activities, train washing, etc. To further enhance this AI, we can, for example, feed the agent and train it with this new type of data. And having an AI as every single switch, for example, to determine where to best place a train. One of the other way is to train one single super AI which sits at the entrance and then determine where to best place a train. There are numerous possibilities, but just to wrap this conversation up, I would like to show you how this can be deployed to the real world. Once you have trained an agent, you can deploy it to a microcontroller. From this diagram, we know that you just need to feed in the observation state to the agent and it will output an action. Here, I have deployed the agent to a microcontroller, which is connected to a servo motor. It will come in handy if I have an actual model train set, but since I don't, you will just have to use your imagination on this piece of paper. Imagine there are two model trains coming in, one at the top and one at the bottom again. Now you need to feed the agent with the train speed. Now this can be done via a speed sensor quite easily, but again, since I don't have an actual model train here, I'll just change the parameter in the code to mimic the situation. This script I wrote will then query the policy via the Pathmind server, with the state that I sent, and then return me with an action. In this case, since the speed of train A is much slower than B, so the switch doesn't toggle and stay in position. However, if I change the speed to much similar to train B, the switch will then flip. Obviously, it will be more interesting to train more agents and deploy it on an actual model train set. So feel free to sponsor me. Last but not least, I think it will be interesting to see how to actually deploy in full scale. Obviously, the microcontroller will not have enough power to control the movement of the whole turnout. So here is a simplified diagram on how you might be able to do so. You feed the input data through a filter to filter out the noise. The data is then processed and fed to the trained agent. The analyzer then looks at the proposed action and do some final process to the output data. This small signal needs to be amplified via an amplifier before feeding to the mechanic controller that controls the switch. I hope this gives you a brief overview on how simulation models can connect with AI and how to actually deploy it in real life.
Gentlemen, thank you for that informative summary on the two applications. Now Kelvin is going to introduce you to the AnyLogic 8.7 Rail Library features.
Hello, it's me again. In this final session, I will be talking through the Rail Library and introduce some new features that come up in version 8.6 and 8.7. I will use the Pocket Handbook that I developed to go through all of these. For advanced AnyLogic users, this pod might not be too interesting to you, but perhaps you can start typing the questions, and the live version of me right now is probably sitting behind the computer looking through all the questions and answering them. For beginners or people who are still deciding whether to use AnyLogic for modeling, this will give you a taster course, and you might find something useful in here. Okay, let's get started. As I mentioned in the last webinar, I used the analogy of Lego blocks to describe AnyLogic. As long as you know the blocks, you can build pretty much whatever you want. There are no right or wrong way to put the Lego together. You just need to ask yourself and make sure if that is what you wanted. That's the reason I started to create this type of Pocket Handbook series with the aim to let people know their Legos. So I'll start off with the space markup, which are essentially all the visual elements of the Rail library. Then to the actual logic blocks that you will use to build a model. First one, space markup. The space markup is some markup elements that allow the user to see the behavior of the model visually. In here, you can see the straight rail track I drew and the one with some curvature. I will explain this a little bit more later, but circled in dotted blue lines, you can see the position on track. You can also see the railway switch and the position it's currently in. There is a new feature introduced in version 8.6, which is the ability to define a single or double slip. If you are not a rail person, you might not understand what this means. I have created these two examples here for demonstration. Single slip allows you to change direction along the obtuse angle only from or to the switching track. So in this example, I have set the switching track to B, so trains can either go A to B, or A to D, or C to B. It cannot go from C to D. For double slip, trains can go from C to D as well. Don't worry if you don't get this straight away. this Pocket Handbook will be available to download for free. Okay, now let's look at the logic blocks. Train source and dispose. Train source is a block that starts any railway process flow. It generates trains, places them on the tracks in the rail yard, and injects the train into the train process flow chart. You can set the block so that it doesn't place created trains on a track of the rail yard straight away. It is commonly used when you need to pass the train agent to the regular process flowchart, where it can go through delays, queues, decisions, etc. And you place it on the track of the rail yard later on. As you can see in this example, the train just spawned and then disappeared. You will need another block in order to move the trains. Similar to any other library, you use the train dispose to remove a train from the model. Train move to block. The train move to block is the only block that controls the train movement. A train can only move while inside a train move to block. The train can move forward or backward. The train can have a target position where it should get, or just move without a target. In this example, I have set it to move to a position on track. A route can be specified explicitly as a sequence of tracks or calculated automatically. If you choose to specify the route explicitly, you should enter the track where the head of the train is located as the first track, and then all other tracks the train should go by in the correct order. If the target is specified, the target track must be the last track in the sequence. To let the train move to calculate the route automatically, you need to specify the target track. In the latest version of AnyLogic, you can block or reserve a particular track. In this bottom example, I can place a block to the upper track. This will then force the train to wait behind the turnout. And you can block it again by pressing the button, and the train will accelerate again. Of course, this can all be implemented with code and happen automatically instead of manually pushing these buttons. Train couple. This block couples two trains and makes them into one single train. The two trains to be coupled must enter train couple at different input ports and have two ends touching each other. Train couple contains two queues, one for each input port, where trains wait to be coupled. When a train enters train couple via one of the ports, the block checks if there is a train in another queue that can be coupled with it. If yes, the trains are combined into one single train and leave train couple. If not, the train remains in the queue. A single train couple block can handle coupling of trains on several tracks simultaneously and independently. Train decouple. As the name suggests, this block decouples a given number of cars from the incoming train and creates a new train from those cars. The speed and acceleration properties of the original train are copied to the new train, but you can certainly redefine their properties as well after they decoupled. No rail cars change their position during decoupling. Rail settings. Rail settings is a detached block that offers the lower level interface for the rail yard management based on Java functions and callback technique. You can use those callbacks, for example, to collect statistics on the rail car movement throughout the whole rail yard. As you can see in the Properties window, You can define the behavior of all the trains. So exit enter or exit yard, on at switch, enter or exit the track, etc. You can customize the train behaviors here in bulk. Train enter and exit. Train enter takes the train agent and places it on the railway track, whereas train exit removes the train from the railway network and passes the train agent onto the regular process flowchart, where it can go through delays, queues, decisions, etc. Together with train exit, the train enter block is used to model part of the train movement on a higher abstraction level. You can imagine it as a portal. In this example, the train tries to go through the mountain. We might not want to care about what's happening inside, so we can just use the train exit and train enter with a delay in between to mimic the train going through the tunnel. So this pretty much covers all the blocks from the Rail library. You might be thinking now that there aren't actually that much blocks in this library. That's true, but that is also the beauty of it, I think. If used done properly with the combination of blocks from other libraries such as the Process Modeling Library and state charts, you can create a really powerful model. As I always said, one of the key advantages of building models using AnyLogic is that you can build it as simple as you want or as detailed as you wish. So you only got 2 weeks, we can abstract the model for you. Or if you got 6 months, I can dive down and model every details. So this time, since we got some time, as bonus material content, I have used roughly 30 minutes to put together this simple model that captures all the blocks we talked about earlier. We talked about the Lego blocks, and now you can see how they can all fit together. In this model, a train is spawned at the top left-hand corner of this layout. The train then gets decoupled and separated out. One part goes straight into the maintenance shed and the other goes to the stabling area. The train at the stabling area stayed for a period of time, as shown in this delay block. The train at the maintenance area and then went through some sort of custom maintenance activities, as shown in this custom block. The train from the stabling area then tries to leave the depot, but before doing so, it waits for the train at the maintenance area. They then coupled together and leave the depot. I have also included a simple graph which essentially shows the amount of switch usage, or the amount of times the switch has been toggled. These are just some sample KPIs, of course, and we can build a much more complex model with more interactive dashboards. So hopefully this gives you an overview on the capabilities of AnyLogic. If you want further clarifications on any of the content, feel free to drop us an email or to AnyLogic. If you think your team might be interested to test out AnyLogic, drop us an email as well, and I'm sure we can work something out. I hope you enjoy the materials I put together for you. It's a shame that I haven't got a model train set, but who knows, maybe I'll get sponsors with something next time. Thank you for attending the webinar. I will now pass back to Anand to conclude the webinar, and then we'll switch back to live mode to answer some of the questions you may have. If we don't have time to answer all your questions, don't worry, we will contact you via email again. Last but not least, stay safe and well. Thank you.
Thanks to everyone who's joined us for today's webinar, and thank you to WSP for allowing us to share some of the outputs of our ongoing partnership. If anything we've talked about today sparks an interest, we've added our contacts and websites for you to connect with us directly. We'll now open up the floor to questions from the audience based on what we've presented. So the first question that we've got is from Dalibor, HRG, and his question is, are there any interpretable solutions of RL models? For example, if V1 is less than some value of V2 is less than some value, then switch. And I'm assuming that he's talking about the logic between variables within a rail model based on RL. So Kelvin, I don't know if you've got something on that you may wish to answer.
Yeah, so I'm fairly sure the V1 stands for velocity 1 and the velocity of train 2. So again, as I mentioned, you can really write a simple rule-based model for that. You don't, you can write it based on speed, distance, and time calculation, and you don't actually need a reinforcement learning AI for that. But my point is showing is that at the moment I'm just feeding in the observation state as the velocity for both trains, but then obviously we can feed in with other observation data as well. And I think that's related to one of the other common whether we can show some more complex AI model, and we certainly can. But I constantly work with Pathmind, so we can discuss something that for that. So to show more complex model. I think that there are a couple more, but it's just because of time I wouldn't be able to show them today. So it's basically just a simple RL model that looks at both velocity of trains and then slot the trains at the right place. I hope that answered the question.
Yeah. So next question that we've got is from Ed in North America, I believe, and it's related specifically to visualization. So Ed's asking whether we've used any elevation parameters in the model. So it's a visualization question, but also obviously a model functionality question as well. But he's asking whether we've used any of those and whether they have any impact on the model from a functionality perspective, or if the effects of those are negligible, and whether things like the angle of track versus horizontal elevations have any bearing on what we've seen, especially because some trains may go upwards or downwards in terms of elevation. So I guess Will or Kelvin, in terms of the two cases, I'm not sure whether that was something that you guys kind of built the model around in terms of form or function, but I think that's what Ed's asking.
Go on, Kelvin. Go ahead. You go, Kelvin, first of all.
Yeah, okay. So basically, the horizontal elevation, or in the rail industry, that different terms, and the cant of the track, and how like the angles of the track, or how they call it. So in the depot modeling scenario, since the speed of the train, is comparatively slow compared to high speed on high speed rail way. So I think within the depot is moving relatively slow. So the horizontal elevation doesn't actually matter in this case. But if you want to do that, having the speed change it according to the angle of the track, etc., you can do so by implementing some custom functions on the actual train move to block itself. So you can set the train speed that reads according to a function instead of a fixed speed, let's say.
Well, I don't know if you've got anything you'd like to add to that.
Yeah, so most of the work we've done has been around depots, and I suppose the geography of a depot is relatively well controlled because you build it, and the train speeds are quite low. Just trying to think of an instance where gradient would be in my world where I might use gradient. I suppose it might be if I was modeling a short section of track, maybe a particular junction that people were interested in, which was in a more natural environment where you do have different gradients. You might need to do something there. I think you can control the speed of your train on the fly to an extent, I think, can you not, Kelvin? So and you could probably do that on a distance-based analysis. So if you knew how the gradient of the track was changing along a piece of line, then I think you could write a function to set the train to change its speed according to its location along the track. I suppose you'd need to do a little bit of the train physics yourself to determine how much it would slow down by as it hit the gradient. But I mean, again, you could probably code that into AnyLogic if you wanted to, because you can pretty much do anything you want. It's just a matter of how much time and energy you've got to do it.
Yeah.
But yeah.
Yeah, no, wonderful. Thanks. Well, I think that, yeah, hopefully that answers your question, Ed. And, you know, if you do have any more, of course, as we said, our emails are there. So in the state that we've got in terms of time, I think it might be good for us to maybe go through these questions rather than me kind of picking them out individually. Will, Kelvin, I don't know if you've been seeing these as they've been coming in, if there are any particularly that you would like to answer that are of interest in terms of what you believe might be of interest to the wider group. Feel free to just jump in and say you're going to answer this, because what we can do, everyone, is at the end we'll capture the questions that we weren't able to answer and try and respond to you individually as well.
I could see one about the HS2 model. Did you use it solely for visualization or also for experimenting and optimization? So it was a validation tool, really. So we were kind of trying to explore what was possible within that depot. So I suppose in that sense it was analytical and experimental. The visualization elements were really useful. They always are in AnyLogic, really. Optimization limited, I think. Again, it's this is where the AI aspect that Kelvin's been working on would come in. I don't think I'm doing us a disservice at WSP to say we're kind of one stage behind Kelvin in terms of we've got a pretty good handle on how to run models in AnyLogic in a kind of deterministic sense. But when it comes to artificial intelligence, that's our next step, really. So yeah, I hope that answers the question.
Well, yeah, and well, hopefully that's a good reason for us to maybe discuss a partnership between DSE, WSP, and whoever was asking the question as well. So yeah, wonderful. Just from my side to answer a couple of quick questions that have come in from Rashid and also from somebody further down in terms of the 8.7 features. I'd be happy to share some more detail with you guys on that post the webinar. In terms of more complex DRL models, as Kelvin rightly said, obviously we're a bit short on time today, so we can't provide a mass amount of detail around those, but we'd be happy to have a discussion about those afterwards, so please feel free to email us. And yeah, in terms of the 8.7 features, we'd be happy to, I mean, these slides, or at least some of the slides that aren't under confidentiality, will be released, so we can share some of those 8.7 features with you guys, and they'll of course all be in the book as well, in the Pocket Guide book, so they'll be there as well. Any other questions from yourself, Will, that you'd like to pick up on, or Kelvin, before we finish up the session?
Yeah, I mean, obviously there's still a huge amount of questions that I haven't answered yet. We will for sure, I mean, email you guys about the answer to those questions. Maybe I can just randomly pick a few ones. So again, so Rashid asks if the DRL can be implemented without using Pathmind, just by using our lib and on-prem servers. Yes, that's yeah, as I mentioned, is completely doable. So at the moment, the supported libraries, Pathmind and Microsoft Bonsai, which has got all the existing functions or libraries, the blocks in it. So it basically helps you to create an AI model fairly easily, compared to you using our lib, where you connect to the AnyLogic model yourself, which is doable. So although it's in Python, So the hourly framework is in Python, but then there are many ways to do that and communicate with the AnyLogic model. So yeah, that can be done.
Wonderful. All right. Well, everyone, listen, thank you very much for your time today, and thank you for all of the questions at the end. I'm sorry we weren't able to get through them all, but there was a lot more than I think we were expecting that suddenly appeared at the end. So what we will do is take these questions offline, and we'll put some answers out to the people that asked specifically. And as I said at the beginning, just now, we'll also be sharing the slides that we can with everybody publicly, as well as putting them up on our website and on LinkedIn. So thank you very much for attending, and yeah, we look forward to speaking to you guys as more of the work in AnyLogic 8.7 and specifically within the Rail library unfolds, and hopefully you'll be able to see an update from ourselves and Will in the coming year or so with another webinar on some of the later projects that we've begun to do. So thank you very much for all of your time, and look forward to catching up with you again soon.
Thank you.
Okay, cheers everyone. Thanks for all the questions. I'll endeavour to go through them and get back to you. Cheers.